Hello, my name is Abdollahpour, and in this video I'm going to have a short self-introduction. I'll cover what I know, what I believe, what I can do, and a sample project that helps to understand things better. Okay, what I know. I'm going to list a set of technologies that I'm familiar with. The list could be much longer, but I mentioned those that I worked with them recently and ignored the others. For programming languages, I have a long history with Java and JavaScript, recently Kotlin, and a little bit of Go. For database, we have a lot of choices based on our requirements. I use PostgreSQL for SQL, MongoDB for document base, and etcd as a distributed key-value store, and more. For frameworks, Spring Boot for large complex services or monolithic applications, HTTP4K for small and mid-sized services, Express.js for tiny services with limited functionalities, or for those that are based on some great NPM packages and use it as a glue. As we know, testing is crucial, sometimes more important than the code itself, and it could be hard sometimes. So we have to come up with excellent choices for any specific type of testing. I use JUnit for unit testing, Spring Test for Spring Boot services, Wiremark for mocking HTTP servers and mock external dependencies, Mockito to mock internal dependencies, Puppeteer and Selenium for end-to-end testing, JMeter for load testing, Storybook for developing and testing UI component in isolation for React, and Jest as a generalized JavaScript testing framework. For technologies, Kubernetes as container orchestration for our microservices, and much more. It's one of the best tools I've ever worked with. Jenkins as automation server for our CI/CD pipelines. Kafka as a streaming, processing, and messaging platform, AWS as on-demand cloud computing platform, and Helm to help to manage the complex setups on Kubernetes. Of course, we can add many more to this list. For documentation, Swagger to document our endpoints for our external integrators, UML for internal and technical documentation in our team, and Confluence to host and manage them. For methodologies, Scrum and Kanban as a lean methods to manage and improve work across our team. For architecture, I have a great experience in microservices. It not only helps to arrange an application as a collection of loosely coupled services and scale them out easily, but also help us to split the business components into services that can be developed and maintained separately. Also, I'm familiar with event-driven architecture and serverless architecture and some tools around them. For programming paradigms, I've started programming using object-oriented 15 years ago and recently got more familiar with functional programming patterns. I've defined a set of principles for myself. I believe in simplicity. By simplicity, I mean to use strategies to make a difficult and complex system easy to understand, design, and build, and more importantly, transfer the knowledge of it. If we build a very advanced and sophisticated system, but we do not be able to transfer the knowledge to other engineers in a reasonable time, that system will eventually fall apart. Start small. Almost any piece of software that we develop is connected to a business. The software evolves from the feedback that we get from that business. We don't want to build something that doesn't have any value for that market or business. Learn fast. I set a chain of small things for myself for a long journey, so I can manage my time and do not get frustrated. We build our knowledge upon the achievement of others. It's common perception that some engineers think that they can make things always better if they implement it again. For any piece of software we develop, we have to list all the pros and cons and see if we can achieve something with a reasonable time and budget if we re-implement it. Keep this stack updated, but not at all costs. Not every company is like Google. We need to keep things updated, but being on a very edge has a significant cost for the company since they are not stable, not enough documentation and sample provided, and not many developers around to hire for that. What I can do for your team? I'm familiar with the entire software development lifecycle. I can design and implement a low-level system, a larger scale complex backend system, up to a web and mobile frontends. I can manage your team in a very efficient and modern way using some approach that lead enterprises are following nowadays. Translate business needs into technical requirement and vice versa for getting feedbacks. I'm familiar with engineering modeling languages like UML to model the artifacts of the system. Finding new engineers and onboard them is crucial nowadays. I can help you to modernize the onboarding process in a way that a new engineer with base requirements for that position can be productive in a few weeks. Here is a sample project. We are going to build a search engine for searching jobs and services using microservices. Considerations. It's a good practice. We'll list up some principles that we believe they are matter in this project before making any technical decisions, so things get value based on them. In my project, they are decoupling applications into a manageable service that are faster to develop and boost up productivity in our team. Keep services decoupled as much as possible. Keep things immutable. Build services as a reusable units using strongly typed languages for a core part which holds the main logics, and write clean testable code. And here is our design visualization. At the first glance, it's a bit intimidating, but if you are familiar with microservices, with a little bit of explanation, you will see it very clear and self-describing. In this project, everything is on Kubernetes. We use Nginx Ingress for managing external access to our services in our cluster. We federate the authorization to a specific service called macroauth request. In the first request, macroauth request uses Google to identify the user, and for the next request, it checks them using JWT token. In a case that we need more information about the user that Google doesn't have, like roles of that user, or to check if the account is blocked or not, etcd helps to enrich the user's data very efficiently. We can always update these details using role management service, which is also connected to etcd and has permission to update the data. Our core service provides the core functionality of the system, which in this case is the search API. We use Kotlin to have the advantage of a strongly typed system. We also have another service called Macro Image Manager. Optimizing, managing, and distributing images could be a complex task. It's also a very resource-consuming process, and it needs a huge set of dependencies in our service, which may cause vulnerability and complexity. Macro Image Manager helps us to solve all these complexities and take them all out of our service. We can also scale it out much easier when it's required. We also have a set of front ends to manage search data and users for admins, and also a web progressive app which makes the user able to access our services via web or mobile as a mobile application also. We use FluentD to aggregate and transfer logs to a centralized log aggregator like Datadog or Logly in this case. The most important outcome of such a design is decoupling. You can literally use a different team or developer to develop each of these services with a very brief documentation and without having complete knowledge about the entire system and other services or the infrastructure. continuous deployment, or continuous delivery in some cases. It makes software development faster, lead to higher quality products. It's even more important in some architectures like microservices to follow that. When we create a new branch or push a change, for example in the feature branch, we automatically run unit, integration, and acceptance tests and build a project. Without passing these checks, the developer is not able to merge the changes into a develop branch. When the PR merges into develop branch, we not only run unit, integration, and acceptance tests again, but we also build a Docker image and deploy the latest version to a temporary dev environment and run end-to-end tests. We not only test the code here, but we also check for configuration and integrations with external dependencies. If we all pass, we can go forward and merge it into master. And finally, when we merge into master, we run everything again, and this time we update our staging server, which is almost same as our production environment. Here is the part that we can have some manual testing if it's required. If everything is fine, we just run our deployment pipeline and we update our production server easily and safely. I published some reusable parts of projects as open source projects that you can check on my GitHub account. Feel free to contact me if you need further information about other parts like core, user management, or details about pipelines and Kubernetes setups. I hope you enjoyed this video and goodbye.